RCO, report range, go for launch.
Ranges go for launch.
LCDR, this is LVD, go for launch.
Roger.
July 2003.
On.
The United States prepares to send a robotic land rover to explore the planet Mars.
20 seconds.
The quest: to hunt for water and for signs that humans are not alone in the universe.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, main engine start, 0 and liftoff of the Delta rocket with opportunity.
The transients at liftoff. Engine position looks good. Recovering nicely from the liftoff transients, and the solid rocket motors are increasing their thrust during their 75-second burn. Main engine chamber pressures holding steady.
The heavens above have long been a target for exploration, for determining humanity's role in the great scheme of things. Some find the answers in religion and spirituality. Others find comfort in the hard facts of science. Earth may be a rare environment, uniquely designed for nurturing living organisms. But as humans explore the creation of the planet, the realization grows that the answers to the origins of life may lie beyond earthly bounds.
Nobody knows how or when life began on Earth, and really the only way that you can begin to evaluate when or how life began is by examining the geological records.
Dr. Stephen Moses of the University of Colorado is examining some of the planet's oldest rock here in Greenland at the top of the planet. When Earth was originally formed, it was a ball of molten rock, so hot no organic materials containing living organisms could have survived. As it cooled, the Earth would have consisted only of sterile oceans and barren rock.
The early Earth's surface was not rich in organic compounds. It was a surface that was dominated by compounds that are not particularly helpful to get life started.
And if no organic material could exist on such a barren planet, life on Earth may have started elsewhere.
My personal opinion is that since space is so rich in these organic compounds, it must have played a role. I don't think it's unreasonable to invoke the space medium as a source area for raw materials to get life started, because after all, space is close. Space is only about 30 kilometers that way. All you have to do is take material from up there and bring it here. That's not far. And that is an infinite resource.
More than 4.5 billion years ago, the solar system was formed from huge clumps of ice, dust, and rock left over from the creation of the universe. These clumps, called planetesimals, collided, growing in size as the larger planetesimals drew in smaller objects. Planet Earth was born from these molten collisions. The smaller objects not absorbed during the planet creation process were drawn to the outer edges of the solar system. There, just over 3 light-years away from the Sun, these comets and asteroids turned into an immense cloud called the Oort cloud. The solar system, with its sun and planets and stars and Oort cloud in tow, circles the Milky Way galaxy once every 225 million years. However, the 200 billion stars in the galaxy don't follow uniform circular orbits. They shift with each revolution. That sometimes brings the Sun and the Oort cloud into close contact with other stars and interstellar clouds. These close encounters can disturb the Oort cloud, spinning comets trailing long tails of cosmic debris out of their normal orbit and directly into the Earth's path.
These occur when a star comes very close to the Sun, perhaps within 3,000 astronomical units, where an astronomical unit is the Earth's distance from the Sun. Or when we encounter a giant molecular cloud in the galaxy. These are very large clouds of interstellar gas where stars are forming. And these can really shake up the Oort cloud and throw many, many comets in what we call a comet shower.
These comet showers figure into one of the Aboriginal myths of creation. For some Aborigines in Australia, this is their holy land, the birthplace of humankind, a link between Earth and the heavens above. For these Aborigines, each star in the Milky Way is a dancing goddess. The legend goes that long ago, one of the goddesses lay her baby in a cradle to rest, but the cradle rocked, and the child fell to Earth. The impact left this jagged 3-mile-wide crater in the desert of the Australian interior, and, so the story goes, created life. Scientists of today think those Aborigines may well have got it right. Impact craters like this sprinkle the globe, evidence of massive collisions between asteroids and comets and planet Earth. Scientists now believe these stellar collisions brought to our world organic elements of life from deep in outer space, creating the rich and varied tapestry of living organisms we've come to view as what makes Earth unique in the universe.
Hey, that's 2-8. Okay.
Instead of photographing Soviet missile silos, this former U-2 spy plane roams the skies above, collecting dust, space dust. Earth's atmosphere is full of microscopic material shed by passing comets. While cruising at 65,000 feet, 12 miles high, the pilot will deploy these oil-coated plexiglass plates. For every hour aloft, one of these plates will catch just a single particle of space dust. These particles are debris coming off the trail of asteroids and meteorites. Called micrometeorites, they weigh a mere 1/1,000,000th of a gram, hitting the Earth at a rate of 1 particle per square meter per day.
Well, the particles have told us a very interesting story.
University of Washington astronomer Dr. Donald Brownlee is the father of micrometeorites. Brownlee believes these dust particles, also known as Brownlee particles, hold the answer to the origins of life on Earth.
These, we believe, are the most primitive materials in the solar system, and they are materials that are created along with ice to form cometary bodies and also perhaps asteroids in the early solar system, and they are in fact preserved pretty much in the shape that they were when they formed 4.5 billion years ago.
Brownlee is searching for microscopic organic materials embedded within the Brownlee particles. Organic materials from deep space that may have been the first living material to arrive on Earth.
So they have a very large organic carbon content, and we believe that this carbonaceous material is certainly a major contributor to organic material on the Earth. Right now, at present times, there are thousands of tons of this organic material falling on the Earth every year. And early in the history of the solar system, when life was forming, about 3.9 billion years ago on Earth, the flux of this material was probably even much higher. So this has been a natural source of organic material falling on our planet throughout its history. And it may have played a major role in the origin of life. We actually don't know.
To understand the role early comet showers may have played in bringing life to the planet, scientists look first to the Earth's cosmic sidekick, the Moon. The lunar surface is completely pockmarked with craters. Each divot indicates where an interstellar object such as a comet crashed into the Moon's surface.
The Moon is close to the Earth. We're like father and child. And whatever is happening on the Moon is happening here on Earth too. The problem with the Earth is that we have erosion, we have the atmosphere, we have plate tectonics. There's not much of a record left from the last 3 billion years on the surface of the Earth. But our neighbor, the Moon, preserves a beautiful record of everything that's happened to it over the last 3 billion years. So the presumption is, and nobody disputes this, that the impacts on the Moon are a good reflection of what's been happening on the Earth. And that's really what our interest is.
When the U.S. spaceflight Apollo 14 touched down on the Moon in February 1971, astronauts Alan Shepard and Edgar Mitchell scurried through the gray lunar dust collecting geological samples from craters on the lunar surface. Discovered within these samples were a multitude of microscopic glass beads. When a comet hit the Moon, the lunar rocks melted and scattered. When the liquefied fragments cooled, they solidified into these tiny glass droplets. Richard Mueller's team of researchers at Berkeley are dating these glass beads, enabling them to determine the age of nearly 150 different impact craters on the Moon. Knowing the age of these lunar craters gives Mueller an idea of the age of the craters on Earth. Prevailing scientific theory states that the number of impact craters should decrease over time as space debris resulting from the creation of the universe becomes less abundant. Mueller's data confirms this theory is true for the Moon, so Mueller believes it is also true for craters impacting the Earth.
Cratering comes about because there's debris in the solar system, and eventually we bump into it. The amount of debris decreases slowly with time, and so we expect the number of impacts to go down with time.
But then, to Mueller's great surprise, the glass beads began to indicate that 400 million years ago, the cratering rate increased rapidly. No one knows why.
That means the Earth also underwent this increase 400 million years ago to a level that was much higher than it had been for 2.5 billion years. Initial form of life developed in that 2.5 billion years to some very primitive life forms. But most of evolution took place during this period of 400 million years when the bombardment was 3 to 4 times higher than it had been previously. This certainly played a role in the evolution of life on Earth.
When a graph of the cratering rate on the Moon is superimposed on a graph showing the number of species on Earth, the increase of both happens simultaneously. This points Mueller to the hypothesis that diversification of new species on Earth was stimulated by cosmic impacts. The same result did not happen on the Moon because the lack of a lunar atmosphere and lunar water precluded the ability for life to form.
Many of us grew up believing that survival of the fittest meant the competition of one species with other species and the stronger species won. When this catastrophe takes place, you may be very good at competing with other species, but unless you're adapted to survive the catastrophe, you really can't endure. There's an added advantage to flexibility, to adaptability. These are just the sort of traits that, for example, intelligence brings with it. It may be that the existence of these catastrophes, impacts on the Earth, is what's driven evolution towards a higher intelligence and flexibility. The most flexible animals on the Earth right now are humans.
250 million years ago, the continents on Earth formed one giant landmass called Pangaea. The red dots on this map show the confirmed locations of impact craters here on Earth. Over geologic time, Pangaea broke apart, and the continents drifted in a process called plate tectonics. This shifted the location of most impact craters and buried some. Despite the constantly changing geography of Earth and the withering effects of erosion, the ages and locations of nearly 200 craters have been discovered so far worldwide. 65 million years ago, it is widely believed a single comet or asteroid crashed down into the Yucatan Peninsula of Mexico, wiping out the dinosaurs. 30 million years later, a smaller impact eradicated nearly all life along the eastern seaboard of the United States.
So right here, we're standing above the rim of the crater. You can imagine that this arch of the beach here, if you could see down 500 meters beneath this surface, you would see the edge of the crater.
What today is the heavily populated area surrounding Chesapeake Bay in Maryland once was tropical forest covering the mountain slopes and lush shoreline. The sea level was higher than today, and the world was much warmer. Large rhino-like mammals and hippopotamus-type creatures had come to dominate following the dinosaurs' extinction. Just off the coast, gigantic prehistoric whales plied the oceanic waters in search of food. But then, what happened next shows the devastation a comet or asteroid traveling at supersonic speeds can wreak on Earth. In a flash of light, millions of tons of rock must have been pulverized. The 60,000-degree Fahrenheit blast sent molten shrapnel back into outer space, which then came back with devastating results.
Animals and plants in the immediate vicinity within 600 miles of the blast would have been devastated.
Locally, the region would have appeared dead, but the climatic disruption would have spread across the northern reaches of the globe. Life would return to this region only very slowly.